We are probably going to go to the laboratory and do this for our first lab, I guess. Okay. So what we need to talk about is how we're going to collect gas in a lab. Okay, and you have some diagrams there. We'll get to those in a second here. So we're going to go through this. I'll make some notes here for you. Please make sure you copy them down so you know what we're going to be doing here and how we're doing it. And again, we'll get to some pictures and we'll kind of hopefully understand how to do this. Okay. So I will also give you a demonstration on Monday for the first one. I'll do a quick demonstration and then you guys are going to be on your own. We're going to have limited time, but we'll be okay for time. But we'll have to do 3 experiments in the class time. Okay, so we need to understand kind of what's going on here, and we need to get in there and get going, kind of thing. All right. So one of the safest ways to collect gas in a lab is to use what we call the downwards displacement of water. Okay. Basically, what happens is we're going to take a graduated cylinder, and that's actually a little bit of a lie. We're not going to use a graduated cylinder. We're going to use something called a gas cylinder. So let's switch that. Okay. Gas cylinder. Let's switch that. Now you can use a graduated cylinder. There's nothing wrong with a graduated cylinder. I like the gas cylinder. It's specifically designed for capturing a gas. So I like it a little bit better. Okay. So we're going to fill it with water. So we're going to fill this gas cylinder with water. We're going to flip it over, and we're going to put it into a sink full of water. Okay. What's going to happen then is you're going to take your thumb off of it, and at that point we should have a glass cylinder full of water, or a gas cylinder full of water, and we should have a sink full of water. Okay, basically. And it should remain full of water because, of course, there's pressure. The pressure on the outside is equal to the pressure on the inside, so we should have this glass tube, this glass cylinder. It's a long, skinny tube. It's about that round, okay, about that round, and it has some markings on it for volume. Okay, and we're going to collect the gas in there. All right. The trick to this procedure is not to let any air bubbles into the cylinder. I will show you what to look for that, but we don't want to let any air bubbles in. If we let air bubbles in, they are going to take up a volume. So oxygen would take up a volume in this gas cylinder, and we don't want any oxygen. What we want is the gas that we're trying to collect. Okay. The gas bubbles are going to travel through the gas cylinder, so they're going to go up through the water, and they're going to collect at the top, okay, of the gas cylinder. And when they collect at the top, they're going to push the water out the bottom of the cylinder, and you're going to see that in your diagrams there, okay. And then it says here we need to adjust at the cylinder so that the water level inside the cylinder is equal to the water level outside in the sink. That's really important because at that point, the pressures will be equal to each other. Okay, so I'm going to write down here pressure. Pressure of the atmosphere is equal to pressure inside. Okay. Now, again, this is not. I know we haven't got kind of what you're looking for yet here, but. And again, we'll look at the diagram and we'll talk about all the things that you're going to collect from this on Monday here. But you can get the volume of the gas from the cylinder. So you're going to get the volume of the gas that you collect. Okay. You have to pay, I'm going to tell you this a couple times, you have to pay attention to the units. Okay. It'll say on the gas cylinder what units we're using. Make sure you're paying attention to the units. Otherwise, we're going to get some crazy numbers. Okay. The pressure is from the barometer in the room. Okay. Now, barometer just simply measures the atmospheric pressure in the room. Okay. We're not going to go outside. We're not going to look it up on the Weather Channel because that's going to be the pressure in wherever the weather station is. We're going to look at a barometer in the room. Okay, again, make sure you check the units, make sure they're the right ones that we need to use. Okay, and we're going to get the temperature of the water. And of course, we're going to get that through a thermometer. Okay, we're going to put a thermometer in the water. Okay, so we're going to put a thermometer in the water. That is going to tell me two pieces of information actually, because we're going to get this gas to go up through the water. So that's going to tell me the temperature of the gas, and it's going to tell me the temperature of the water, which I need to talk about later. Okay? So we have P, V, and T. Okay? What formula do we need to use here? P, V, and T. Let me ask you this. Do you have another P, V, T to compare this to in this question or so far? So what formula do you need to use? On Friday, you would use what? Ideal gas law. PV equals nRT, right? You have P, V, T, R, and you can find N. You will find the amount of the gas collected. Okay? Now, that is not the answer yet. So that's the first part. Okay? Good so far? Questions? Okay? Again, pressure comes from a barometer. The volume is going to be in that gas cylinder. We're going to see that. Okay? T is going to be the temperature of the water, which is the temperature of the gas, and R we know as well, 8.31 volts. We're going to find N. Okay? We're not done. Okay? It looks a little something like this, and I want you to label your diagram as well. Okay? And we're going to change this a little bit because we're not doing this exact same way here. Okay? This right here, this is a graduated cylinder that they have. It's upside down. Okay? We're not using a graduated cylinder. We're using a gas cylinder. Okay? So this is going to be your gas cylinder, and it's actually kind of more rounded at the top like this. So this is your gas cylinder here. Okay? You are going to fill up this gas cylinder completely with water. And I'm going to show you how to do this. You just fill it up with water, and I'll show you how to do that properly. It seems silly, but I'll do that. And then you're going to put your thumb on top, and you're going to flip this over and put it in a sink full of water. Okay? You're going to take your thumb off, and hopefully we don't get any air bubbles. And if we do, we'll start over. But that's basically how we're going to start this. Okay? We've tried different ways to do this. Okay? And it turns out what we did in the past works the best. We bought a kit for this. We did lots of different options for this, and it turns out that the kit sucked, et cetera, so we don't do that anymore. We're not using a gas generator. We're going to use a Bic lighter. Yeah. And we're going to put it in the water. We're going to use a Bic lighter. You can label it if you want. We're going to put it in the water, and we're going to collect some gas from a Bic lighter. Okay? So we're going to actually put that right in the water. This is my sink right here, by the way. Sink. And we're going to talk about how my plan is to have this already filled up for you, because we kind of like it. It's better if it's at room temperature, just because we don't want it too cold or too hot. But it's better if it's just kind of room temperature. It kind of normalizes all the data we need to kind of collect here. It doesn't have to be, but it helps a little bit. Okay. So this is our sink, and our sink has this water in it here. Okay. So the sink has this, and that's my water level in the sink. So you can put that's the sink level or whatever, full of water. Okay. We need to make sure we collect enough gas. So this is the important part. So I'm going to start letting some gas out. You're going to see the bubbles travel up. It's quite amazing. And they're going to collect up here. And this is called the downwards displacement of water. The gas is going to travel through the water, collect up here, and you're not going to see anything here, but the water volume is going to start to go down, 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 because we're forcing the water back out the bottom. Yes? Okay? The gas is going to push the water up. And we need to make sure that we line the sink level with the gas level here. Those have to kind of be equal to each other. They have to match up. When they match up, we can say, and this is why they have to match up, the pressure outside, remember we talked about this before, the pressure outside is equal to the pressure inside. Okay? Those two pressures will be the same when we do that. That's why they have to level. If they're not the same, then the pressure outside is kind of irrelevant, because I don't know what the pressure inside is going to be. Does that make sense? Okay? And even if you're not sure why or whatever, it doesn't matter. Those two pressures those two volumes, those lines have to match up. Okay? And again, we're going to get the following from here. We're going to get the volume of the gas that we collected right there. Okay? Now, you're not going to see, you can't see the gas because it's clear. But you can see where the water level is. And of course, that's all the gas, right? So this right here, this is all gas in here. And this is how much gas I've collected, whatever that happens to be. Again, take note of the units. Okay? Does that make sense? That's the volume of the gas that I collected. I'm going to push down, I don't know if you guys know anything about lighters. You push down a little red tab, right, on the side or whatever, and you just push it and hold it, and all the gas is going to go up. Make sure you collect it all. Don't miss any. Okay? Does that make sense? Okay? And we're going to collect it. We have this here. We're going to get from the barometer. Okay, that's the barometer in the room. And again, we're going to have a thermometer that's in the sink. But the thermometer is going to tell me the temperature of the water. But the gas has to travel through the water to get to the top. Plus, I'm going to have the lighter in the sink. So what my hope is here is that not only do I know the temperature of the water, but I know the temperature of the gas, because the lighter is going to be in the water, the gas has to travel through the water, so I'm hoping that the gas is going to take on the temperature of the water. Okay? It should. I can't guarantee that. Okay? So you might want to remember that for down the road. Okay? But it should. But there's no way to really tell for sure. Okay? All right? So that's what I kind of have there. We talked about pressure, we talked about volume, and we've talked about temperature. Yes? EV, R, find N. Yeah? Okay? Now, the job of our lab here is I want to find this. And I'm going to put little letters here, just so you've seen that before. That is what? Big M stands for molar mass. And I'm going to do it experimentally. So I want to do it based on these numbers that I'm using here today. Okay? I mean, I guess we can maybe check it or somewhere or whatever, but I want to do it experimentally. I want to see how close we are, kind of thing. And whatever happens, happens. But experimentally. Okay? What do I need to know in order to find the molar mass? What? Sorry? Mass and moles. I know the moles, right? I found it already. How am I going to find the mass? Can I take the gas out and put it on a scale and weigh it? How do you normally find the mass of a gas? Huh? No. Because we're going to do it experimentally. And technically, you probably don't know what the molar mass is exactly. How am I going to do it experimentally? How do I find the mass of a gas, Robbie? No, the mass of a gas. Robbie.
Yeah.
Robbie, how do you find the mass of the gas inside a container? Exactly, Robbie. You're in charge of the frickin' propane at co-op.
I just weigh cylinders.
Yeah! You weigh it empty, you weigh it when it's full. The difference is how much gas you put in. Correct? Robbie. Well, you measure it in pounds. We're not going to have pounds of gas here because we have a little lighter. So we'll do it in grams. But you weigh the container before and you weigh it after. Okay? That's how, listen. That's how it works. You weigh the container before and after. Before you start the experiment, you weigh it. Then when you're done the experiment, you weigh it again. And that's how much gas you released, yes? So we need to make sure we remember we got to do mass before, and we're going to subtract the mass after. Yes? And that is the mass of gas. Okay? Wherever. Write it down somewhere. Don't care. Mass before, mass after you're done the experiment. That'll give you the mass of the gas that you released. Just like if you go to see Robbie, you're going to take him an empty propane container. He's going to put it on the scale, right? Write down the number or zero it. You're going to hook up the attachment. You're going to start pumping the propane in. When it's full, you take it off, you weigh it. That's how many pounds of propane you put into there. Same principle. Yes? Only we're going to kind of do the opposite. We're going to do the opposite of Robbie. We're going to take a gas cylinder, lighter. We're going to weigh it before. We're going to release the gas. We're going to weigh it again after. That's how you measure gases. That's the only way you can measure gases, before and after. I'm telling you for the rest of this unit, if you ever get a question about masses before and after, how are you going to weigh the mass of the gas? It's before and after. Okay? So that's what we're going to do. Now, there is a problem with this. Okay? This is not perfect by any means. But look, if I gave you a lighter and I said, okay, let's weigh this lighter. So we go to lab and I give you a lighter and I say weigh the lighter. You weigh the lighter and then you go and do this experiment. Okay? So you've weighed it. Now you put it in the water and you start releasing gas. And then you get to this line here and you stop and you take the lighter out and you weigh it. What's the issue? What's going to happen? I'll tell you again. I give you a lighter. Here's a lighter. And you come over here. Here's my lighter right here. Aiden, here's my lighter. You're going to come over here. You're going to weigh it. Okay. Then I'm going to go stick it in the sink and start letting the gas out. Put it in the water. I'm going to start letting the gas out. I'm going to take it out of the sink and I'm going to weigh it again. Is that a good idea?
No.
Why? Yeah.
Won't the water affect it?
Absolutely, the water's going to affect it. In fact, I'd be surprised if it doesn't go up in mass. Because what weighs more, gas or water?
Water.
Water. It's probably going to be heavier. So when I give you the lighter on Monday, I'm going to walk around, okay, and I'm going to actually throw it in the sink first, so you don't even get that chance, okay? Because we need to start with it in water to get some water in it. First of all, to get it to the right temperature. Secondly, just to make sure that you don't do that. Okay, I'm going to throw it right in the sink. We're going to have the water full. I'm going to throw it right in the sink. You're not going to have a choice. And then I'm going to show you what to do on how to get accurate measurements, basically. Okay, you're going to have to take it out of the sink before you start. I know it sounds silly. Before you even start, I'm going to throw it in the sink. You're going to take it out of the sink, and you're going to dry it off. You're going to shake it out, and then you're going to weigh it. Okay, and then you're going to do your experiment. And then you're going to take it out, and you're going to shake it off, and dry it, and weigh it again. Okay? And you're going to do this experiment 3 times. Okay? So you're going to do all this stuff once, get some numbers for that, and then you're going to start from scratch. You're going to do another one. Experiment number 2. You're going to start right from scratch again. You can, we'll talk about that on Monday, but we're going to get the mass before and the mass after. Okay? And don't worry about that, we'll talk about that. You're going to re-look at the pressure. You're going to look at the volume. You're going to look at the temperature again because it can change, okay, over the course. And you're going to do a second experiment. And then you're going to do a third experiment. And you're going to find, like I said, our job is to find the molar mass experimentally 3 times. So you're going to find molar mass for this set of data, molar mass, molar mass, molar mass 3 times. And then you're going to take those 3 numbers and average them, okay? And that's going to be your final answer. Okay, whatever that happens to be. Yeah.
Did you already check our grooves, Charlie?
I probably will, yeah. Because I kind of have to
Oh, yeah.
for keeping you in the same little area. No.
What?
You get to go with the door.
Yeah.
Yeah.
Probably smarter than Cooper.
Well, I would say that's pretty rude, but he's on his phone right now, so I can't really say too much. Okay? Now, we're almost done. Okay, just listen. So that's kind of what we're doing on Monday, and I'll go through an experiment. We're not done yet, just wait. I'll go through an experiment. We're not done. You got other stuff to copy down yet. So we'll go through that on Monday real quick. I'll give you one example of how to do it, okay, and then you're kind of on your own. And again, I'm going to do an experiment, you're going to do 3, so we got to maximize our time, okay? Now, there's also one more issue with this, okay, and it is the following. So, as we collect this gas, so as the gas from the lighter starts to travel up the tube, and we're collecting at the top, and I'm going to go back to this diagram right here, okay? You're going to see here, for example, I'm going to get some gas, some Bic lighter gas, but I'm also going to get a little bit of another kind of gas collected here. So what's going to happen is I'm going to get 2 gases collected up here, okay? And that just happens, it's nothing that you're doing wrong, it's just that that's what happens, okay? That other gas is actually water gas. Because in water, okay, not all the molecules, remember, in a gas, we have this, right? They're sliding past each other. So this water molecule slides past this one, and at some point, doesn't matter what temperature, you're going to have some free gas molecules of water. Doesn't matter what temperature. At 100, you're going to get a lot of gas molecules, yes? Because you're boiling the water. But at 95, if you ever look inside the pot, you know, when it starts to boil, but when you look inside the pot and you see little bubbles start to form, those are water gas molecules at 90. And there's some at 80, and there's some at 70. You're not going to be able to see them probably anymore, but there is. There's some at 60. There's even some at room temperature. Okay? So, what it means is this. Here's my formula. Okay? The pressure in the room, okay, is going to be this one right here. This is your barometer. Sorry, that says barometer. Okay? Barometer. Now, that's the pressure in the room. That's the pressure in here as well. That's the pressure here. Okay? Or actually, this is the one we want. That's the pressure there. But the problem is we've collected 2 gases in there, okay, to make that pressure. So the reason we do Dalton's law of partial pressures is because Dalton's law of partial pressure says it's the pressure of the gas plus the pressure of the water vapor. How would I get just the pressure of the gas? How would I just get the pressure of the gas? What do I need to do in this formula here just to get the pressure of the gas that we want, the Bic lighter gas? What do I need to do? I need to what? How do I solve for the pressure of the gas here? Come on, somebody. Anyone. How do I solve for just this? What do I need to do? No. Yeah. Subtract the pressure of the water. Okay? And I'm going to do that over here. Subtract the pressure of the water. It says that right here. Okay? To determine the pressure of the gas, the pressure of the water vapor must be subtracted from the total pressure. Okay? Make sure that is the pressure. When we talk about P equals nRT, the pressure of the gas is what needs to go in for P, not the room pressure. Okay, so for example, we go to the lab and it says 105 on the barometer. I'm not putting that in P. That is not the pressure of the gas, that's the pressure of the room. I'm going to subtract the water pressure at a certain temperature to get the pressure of just the gas. Here's a list of pressures, how much water gas pressure is exerted at different temperatures. So when you put the thermometer in the sink and you say, oh, my sink water is at 23 degrees Celsius, my gas is at 23 Celsius, but I also need to pay attention to this number here. That means out of the total pressure of 105, for example, I would take away 2.81 because 2.81 is the water pressure. Okay? I would take that out of the room pressure. That's the pressure, so it'd be 102.19 is what I want to use in P. P equals nRT. Okay? Good? Okay. You have 2 questions for homework. Yeah. Number 2 and number 5. It's on that sheet there right beside the water pressure. 2 and 5. Okay? I encourage you to make sure you do this. 2 and 5. Make a list of stuff that you have. One question's a little tougher than the other one. Make a list. You have enough information, I promise. Okay?